moment it's going orangey red. It's gone red, which means I'm now streaming. Whether it'll stay there, I don't know, but I am back up on YouTube at this second and hopefully it will stay there. Okay, there's an email that's just come from Lee Green, and what's he saying? Just going to have a quick bo peep at that. Oh yeah, I was going to mention that. Alright, yep, okay, I was going to mention that. I was going to segue into that a little announcement. Not a problem. Okay, so alright, apart from the Messier Star Party being postponed, the other thing that's changed in the last, I don't know, I suppose 24, 48 hours perhaps. Oh, there's a spider on the wall. Oh, I think it's safe. There is now a new ASV website. For those that may recall the old website and the way it looked, it was like that, had been like that for many, many years. And as Lee has indicated here, Lee's one of the webmasters for the site. This weekend the ASV are transpositioning from our old website and member management system to something called Wild Apricot. The new system will allow for more automation of our systems, better cyber security, and provide more modern and simplified platform going forward. Always going forward. Please be advised that there are a number of adjustments and inclusions still to be made to the new website, and we ask for your patience as we work through the finalisation of the new website. Members will start to receive notifications from the new platform with renewal notices and other system messages. So yeah, so that's generally an interesting thing. I've had a quick look at the site, and it's a very refreshed looking site, I must admit. In fact, I did have it up on vMix here to show. Yeah, okay, let me bring it up. And yes, I'm still streaming. So for those watching the YouTube stream, which you can find VK3CSJ, just type in VK3CSJ in the YouTube search engine and you'll find my stream, which seems to be still happening. And but for those watching the ATV repeater are also able to see this new refreshed website. And at the moment I can't quite easily navigate around this, but there it is anyway. So yes, so the one of the things that have changed in the presentation is the various links. I used to always make reference to the radio astronomy tab for the broadcast, but that's all disappeared. So I at this point in time making reference to the YouTube and to the Discord. A link to has all gone, so I'm not too sure how I will be able to let people know how to look for the Discord, the link to the Discord channel or Discord link, whatever it might be. But we are streaming tonight on Discord, or at least we are on Discord, I should say, and I can see there's a swag of folks there. Richard has already provided a video stream on Discord as well. So there it is. So I can see Cassiopeia, Richard, Lee's there as well. He says I haven't used Discord for video streaming, so basically I had a monitor set as an audio output rather than a digital mixer. Okay. 380 tickets, he reckons. That was the tally for the Messier Star Party. Bloody hell, that's pretty good, isn't it, Lee? 400 at least. Yeah, what a shame that that's all been brought to a stop. My goodness me. Yeah, okay, just reading more there. And Martin, VK7JAH. Okay, thanks Martin. He's also letting me know that YouTube is working well. Yeah, I'm not sure what tripped it up, but I'm blaming the NBN for that. Oh, so yes, so ASV website's got a refreshed look, and so far it looks very entertaining. The sections look very interesting, and I like the way you've got the radio astronomy link with all the other bits going off. That's quite good, Lee. Excellent stuff indeed. Yeah, the only thing I see that's not included there are the various links to all the other societies around Australia. I would often click on that and go through all the various other societies that are scattered about the country, and go through that. Lots of astronomical societies, but I don't always make reference to that. Alright, look, it's already 15:15 the hour, just full of all that initial waffle. Anyway, all very good. So there it is. That's the latest news in that respect. Okay, now actually it's going to be probably a short broadcast tonight, because I've only got a handful of articles there. But I see that every week, and it's always over 11 o'clock it goes. So the first thing that I will mention here, yes, the first article. We've got a report from Tamitha tonight, our space weather woman, so I'll squeeze her in at some point before the main solar weather report. Okay, first article, and I've really tried to stick to short articles tonight if I could find them. Okay. NASA's oldest Mars orbiter just got a new lease on life. New estimates suggest the Mars Odyssey orbiter has enough propellant left to last through at least till 2025. And this was published March 16. Now I've got a quick picture here of our Mars orbiter, which is ready to go in fact. And each time I do that I lose audio. Thought I had that sorted out. Okay, so what we have here, the caption for this image is: launched in 2001, NASA's Mars Odyssey orbiter has been studying the red planet's surface for more than 2 decades. Prior estimates suggested Odyssey would soon run out of propellant, but new calculations show the spacecraft has enough propellant to last it through to 2025. So, for more than 20 years, NASA's Mars Odyssey orbiter has been circling the red planet, mapping the Martian surface to help astronomers untangle the mysteries of Mars's history. But in January 2022, engineers calculated that Odyssey had only enough propellant to last about 12 more months. It appeared that after travelling some 1.37 billion miles, or 2.21 billion kilometres, and looping around the red planet more than 94,000 times, Odyssey's mission would soon come to a close. Fortunately, that's no longer the case. According to a recent NASA news release, new estimates suggest Odyssey actually has enough remaining propellant to last through to at least the end of 2025. So what does this mean? A spacecraft without a fuel gauge. Mars Odyssey orbiter launched in 2001 with nearly 500 pounds or 225 kilograms of hydrazine propellant. In order for Odyssey to keep its science instruments trained on the Martian surface, the spacecraft depends on 3 spinning reaction wheels to create internal torque. These reaction wheels have to work together to maintain the spacecraft's pointing. Jared Call, Odyssey mission manager at NASA's Jet Propulsion Laboratory, said in the release. But with Odyssey completing a full loop every orbit, you need a way to unload the increasing momentum, he said. That's where Odyssey's thrusters and hydrazine propellant come into play. In order to counteract the building momentum of the reaction wheels, the spacecraft's thrusters fire out hydrazine propellant in short bursts. Unfortunately, Odyssey does not come equipped with a fuel gauge, which means engineers have to create have to get creative when estimating how much propellant the spacecraft has left. One way they do this is by providing heat to the spacecraft's two propellant tanks. The more hydrogen left in the tanks, the longer it should take for the tanks to heat up to a certain temperature. In the summer of 2021, this method yielded an estimate of 5 kilograms of propellant remaining. Another calculation in January 2022 showed just 2.8 kilograms of hydrogen remaining. These results caught engineers by surprise. If the numbers were accurate, the spacecraft must have experienced some sort of failure or leak. And if that was the case, Odyssey would be dead in space within a year. A new estimate of Odyssey's remaining fuel, however, in order to figure out what was really going on with Odyssey's propellant supply, NASA engineers reached out to Lockheed Martin Space, which built the craft, maintains mission operations and provides engineering support. First, we had to verify the spacecraft was okay, said Joseph Hunt, Odyssey's project manager at JPL. After ruling out the possibility of a leak, or that we were burning more fuel than estimated, we started looking at our measuring process. To do this, NASA and Lockheed opted to bring in an outside consultant, Boris Yendler, who specialises in spacecraft propellant estimations. Well, how about that? Yendler wondered whether Odyssey's heaters, which are intended to keep various parts of the spacecraft warm, could be throwing off the calculations by heating up hydrogen more quickly than anticipated. After a number of experiments, the team confirmed Yendler's hypothesis was correct. The heaters, which are located next to the fuel lines that connect to the propellant tanks, were warming up the tanks faster than expected. This made it seem like the tanks had less hydrogen left in them than they really did. Our method of measurement was fine. The problem was that the fluid dynamics occurring on board Odyssey are more complicated than we thought, Call said. After accounting for the heaters, revised calculations recently showed that Odyssey actually has about 9 pounds or 4 kilograms of hydrogen left, which is enough to last through to 2025. It's a little like our process for scientific discovery, said Call. You explore an engineering system not knowing what you'll find, and the longer you look, the more you'll find that what you didn't expect. The more you find that you didn't expect. Full stop. Well, there it is. Alright, that was a interesting first article. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Welcome to, yep, and I forgot to mention more hot coffee. I've got to mention the email address. There's an active email address that's working. The email address, vk3ekh@gmail.com, vk3ekh@gmail.com. Alrighty then, next article. Asteroid, something about an asteroid. In the news this week, there was apparently, I didn't hear it in the news, but there was some discussion on the Coffee Break Net early sometime this week about all the fears concerned about some blasted asteroid and a near causing some sort of event possible with destruction of life on Earth, something like that. There's always things like this. Well, here are the facts. Let me just bring up the article. Oops, hang on. Let me go to vMix. This is the asteroid in question. It's actually an artist's impression, but it's pretty close to it. Keep losing my audio. Okay, what we have here, courtesy of space.com, an illustration of asteroid 2023 DW. Image credit NASA. Asteroid feared to hit Earth in 2046. I probably won't be around. Asteroid feared to hit Earth in 2046 will almost certainly miss NASA, says. it'll miss NASA, but it'll hit the rest of the Earth. It just happens to miss NASA. That's just the way that title was written. There is a comma there though. Asteroid feared to hit Earth in 2046 will almost certainly miss, comma, NASA says. No one needs to be worried about this guy, they reckon. This is published 16 hours ago, so we must be pretty right. After a brief flirtation with doom, the newly discovered asteroid that was given a 1 in 600 chance of slamming into Earth on Valentine's Day 2046 is now highly unlikely to hit our planet, NASA has announced. The asteroid, which was first detected on February 27 and named 2023 DW, Delta Whiskey, measures about 165 feet or 50 metres in diameter, on or roughly the length of a Olympic-sized swimming pool. Initially, given a slim but possible chance of a direct impact by NASA's Planetary Defence Coordination Office, it's that little office that sits on the corner there of the street, the threat posed by the asteroid generated a flurry of news coverage advising readers to reconsider any romantic plans made for 2046. Now, NASA has revised this estimate, putting the asteroid's chance of hitting the Earth at around 1 in 770, meaning it has a 99.87% chance of missing us. The European Space Agency, ESA's Near-Earth Object Coordination Centre, has also lowered its risk estimate, downgrading the impact odds from 1 in 625 chance to around 1 in 1,584. I'll just come back to me. Right. Audio's doing funny things. Still streaming. Continuing on. So, yeah. So it will go down now with every observation until it reaches zero in a couple of days at least, Richard Mossel, the head of ESA's Planetary Defence Office, told Agence France Presse on Tuesday, March 14. No one needs to be worried about this guy, they are saying. NASA tracks the locations and orbits of roughly 28,000 asteroids, following them with the Asteroid Terrestrial Impact Last Alert System, or ATLAS, an array of 4 telescopes that can perform a scan of the entire night sky every 24 hours. The space agency flags any space object that comes within 120 million miles, or 193 million kilometres, of Earth as a near-Earth object, and classifies any large object within 4.65 million miles, or 7.5 million kilometres, of our planet as potentially hazardous. NASA has estimated the trajectories of all these near-Earth objects beyond the end of the century. Earth faces no known danger from any apocalyptic asteroid collision for at least the next 100 years. So get it, right? All you flat Earth people out there, don't have to worry about things. In 2023, if 2023 DW did smash into Earth, however, it would not be as cataclysmic event like the 7.5 mile wide, 12 kilometre dinosaur killing asteroid that struck Earth 66 million years ago. But this doesn't mean smaller asteroids of its size aren't dangerous. In March 2021, for example, a bowling ball-sized meteor exploded over Vermont, not in Melbourne, with the force of 200 kilometres of TNT. 200 kilograms of TNT. Even more dramatically, in 2013, the explosion of a 18 metre meteor above that place in Russia generated a blast roughly equal to around 400 to 500 kilotons of TNT, or 26 to 33 times the energy released by the Hiroshima bomb, and injured more than 1,500 people. So, space agencies around the world are already working on possible ways to deflect a dangerous asteroid if one were to head our way. On September 26, you all would have heard of the DART spacecraft, which was redirected with non-hazardous asteroid Dimorphos by ramming it off course, altering the asteroid's orbit by 32 minutes in the first test of Earth's planetary defense system. NASA has since hailed the mission as a success beyond all expectations. China, good old China, has also suggested it is in the early planning stages of an asteroid redirect mission by slamming 23 Long March 5 rockets into the asteroid Bennu, which will swing within 7.4 million kilometers of Earth's orbit between the years 2175 and 2199. It's a bit far off. The country hopes to divert the space rock from potentially catastrophic impact with our planet. Good grief. 2175 and 2199. Well, goodness me, well, I think we'll be in space by then with warp engines and anti-gravity. Maybe. If we don't blow ourselves up in a war. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, broadcasting since 1988 on this frequency. And we're still there on the TV repeater. We haven't fallen over there, and we are still streaming. Okay, next article was something to do with food. Yes. A scientific salad. A scientific salad for astronauts in deep space. The ingredients were chosen for their nutritional value as well as how easy they'll be able to grow with the limited room and resources available on a spacecraft. Very important. March 15, astronomy.com. An international team of scientists have developed a space salad that can keep astronauts well nourished on future missions into deep space. The salad consists of 7 ingredients: soybeans, poppy seeds, barley, kale, peanuts, sunflower seeds, and sweet potatoes, all in carefully measured amounts. And I've got a picture of it here. Let me just bring it up. Here's the audio again. So that's what you're seeing there. The salad, I've already read that. In carefully measured amounts that can be grown in small enclosures on a spacecraft and fulfill the nutritional needs of astronauts on long duration trips. Researchers from Australia, the UK and the US chose the ingredients based on their nutritional value, growth rate, water and space requirements, and the amount of edible waste produced. Mars exploration will be only possible with fresh grown plants because food payload for 2 or 3 years isn't possible. Xiao Liang, a doctoral student of the University of Adelaide who led the research, tells Astronomy. While the ingredients selected for this space salad are the best options available at this time, the team is now working on selectively breeding them to increase the nutritional value, decrease the required growing space, and increase the ability to quickly grow using hydroponic fertilizers, I should say. Anything that can be eaten, anything that can't be eaten, such as the leaves and stalks of the peanuts and sweet potatoes, will be burned, says Lang. and the nutrients extracted from the resulting waste will then be recycled into the hydroponic system, she adds. Astronauts don't follow the normal circadian rhythm that most of us follow here on Earth. Well, I don't think I do. Anyway, even here, which consists of about 8 hours of sleep, followed by 16 hours of being awake. I certainly don't get 8 hours of sleep, says Lang. Social activities, exercise, and sports here on Earth are also timed to fit that pattern, which means astronauts in space must cope with any differences. The human body also experiences a psychological stress in space, where it is exposed to unusual conditions like microgravity and increased cosmic radiation for relatively long periods of time. Microgravity, for example, causes bone loss, which means that astronauts require more than the usual amount of nutrients like calcium and vitamin D. The nutritional requirements in space are different than on Earth, says Lang, and that means that astronauts on long duration trips will need to consume nutrient-dense foods to offset some of the detrimental health effects spaceflight has on the body, she said. There's another image here. That image above, the title underneath that was a bit of writing on that. It says researchers have developed a salad seen here, made of ingredients that not only can be grown on a spacecraft but also provide optimal nutrition. So that's what you're seeing on the picture right now. And there's one more image here. Where are we? There it is. So, crops for a spacecraft. Crops. To determine the best ingredients for the space salad, Lang and her colleagues began with a selection of 100 crops. They then measured each crop carbohydrates, component fats, vitamins, amino acids, fiber content, and other nutrients. And what you're seeing here, the ideal space salad consists of 7 ingredients: soybeans, poppy seeds, barley, kale, peanuts, sunflower seeds, and sweet potatoes. That's basically what you're seeing there. So next, they used a computational model to identify 10 salads, each with between 6 and 8 ingredients that provided the necessary nutrients at desired levels. These nutritional requirements for astronauts were outlined in a 2011 study conducted by specialists at NASA. The winning space salad was the most nutritious for 10 finalists, says Lang, but it also took into consideration the room each plant would need to grow, as well as the amount of edible waste produced. The computer selected salads that also assessed for their psychological value, which could become especially important for long voyages where astronauts might be faced with eating the same thing every day for years. The colour, taste, texture and freshness of ingredients were all taken into consideration. Food is such an integral part of staying healthy and happy, Lang said in a University of Adelaide news release. As well as the nutritional values and ability to grow the plants in space, we also looked at other important aspects of space diet to promote astronaut well-being, including colour, taste and eating together. The final space salad was put in front of 4 volunteers as part of a test carried out by space psychologist Carolina Rivera Osorio, who is now at NASA's headquarters in Washington, D.C. After eating the salad, one of the volunteers even commented that they wouldn't mind eating this all the week as an astronaut. Yeah, okay. So, one final image to this article. So right now, all human space travel takes place near Earth. That means that astronauts don't need to grow a lot for their own food unless it is part of an experiment. And the image that you're seeing on the screen there is understanding how to efficiently grow food in space will be vital to future success for long duration space flights. That's why astronauts on the space station are already experimenting with growing nutritious plants in a microgravity environment. Oh, goodness me. Finally, an article by NASA's details for astonishing variety of food that's been considered on the International Space Station over the years, including regional delicacies like the Sylvian sausages and samosas and sushi. But figuring out which foods are ideal, suited for consumption in space, is part of the learning curve. For instance, we now know that regular bread isn't really suited for consumption in space, as it goes stale too quickly, and it results in too many crumbs. However, tortillas have been found to be an ideal alternative, which is why they are widely used as a bread replacement. In general, Lang says, astronauts on the International Space Station mostly eat prepared or prepackaged food that is freeze-dried, dehydrated or thermostabilized, which is heat-treated to destroy harmful microorganisms. Nonetheless, spacefarers are still treated with the occasional deliveries of fresh food. This means that astronaut meals on the International Space Station can include meals like chicken, beef and fish, but such meat still must be pre-cooked, as the International Space Station has no refrigerators for storing food. Just throw it out the space store in freezers. Yeah. Anyway, although meat and other space delicacies are an option for astronauts in Earth orbit, during future deep space missions, astronauts will not be able to resupply their food stores through regular resupply missions, of course. Still, final paragraph, I think astronauts can benefit from our vegetation diet, says Lang. Vegetarian food can not only meet the nutritional needs for astronauts, but also provide the opportunity to grow these crops during space missions without worrying about the problem of food supply through cargo. Oh, there it is. Everything gets considered when you go to space, that's is for sure. ASV Radio, VK3EKH. Next article. Star on the brink of going supernova, spotted by the James Webb Space Telescope, March 15. The unprecedented observations were made possible thanks to the James Webb's powerful infrared vision. And we got a picture of this too. There it is. It keeps disappearing. Okay, so the James Webb Space Telescope has captured a stunning view of an exceptionally massive and hot star that's well on its way to going supernova. The star, Wolf-Rayet 124, or WR124, is located some 15,000 light-years away in the constellation of Sagitta, the Arrow. Wolf-Rayet stars, like WR124, are a special breed. These objects are some of the brightest and most massive and hottest stars in the modern-day universe. They also sport intense stellar winds that can clock in speeds of millions of miles per hour. Such strong stellar winds mean Wolf-Rayet stars shed their outer layers at an astonishing rate. For instance, researchers say WR124 has already lost about 10 suns worth of material over the course of its relatively short life. That's about 25% of the star's original mass. But Wolf-Rayet stars, also notoriously difficult to study, and the reason why boils down to two main issues. First, because they are so massive, Wolf-Rayet stars quickly burn through their nuclear fuel. This means that Wolf-Rayet stars, I think I'm pronouncing that rate. Anyway, this means that Wolf-Rayet stars typically only live about a million years before collapsing in on themselves and exploding as a supernovae. For comparison, our relatively petite sun has a lifespan of about 10 billion years, and the smallest red dwarf stars are expected to have lifespans of trillions of years. The second issue is that the particularly powerful stellar winds of Wolf-Rayet stars shroud them in expansive shells of ejected gas, which eventually cool into cosmic dust. These clouds of dust largely block visible light, preventing optical telescopes like Hubble from capturing much detail. Fortunately, this is where the JWST views the cosmos with infrared vision, which is perfect for observing the gas and the dust that surrounds Wolf-Rayet stars. Webb's Near-Infrared Camera, or NIRCam, NIRCam, balances the brightness of WR124's stellar core and the knotty details in the fainter surrounding gas, according to a NASA news release. Meanwhile, the telescope's mid-infrared instrument, MIRI, reveals the clumpy structure of the gas and dust nebula of the ejected material surrounding the star. These observations, captured in June 2022, are not only helping astronomers unravel the mysteries of Wolf-Rayet stars, like WR124, which live exceptionally turbulent and transformative lives, they also may help shed light on why astronomers encounter more dust in the universe than current theories can explain. Yes, you're tuned to ASV Radio, VK3EKH. Okay. Next on the scheme of things, and we're coming up pretty much to the end of this. I haven't read through this yet, but this could be interesting. Yep, alright, hang on. There's a picture. Will we ever figure out how to defy gravity? Have you ever thought of this? Defying gravity is easy on Earth, but going into space complicates things. March 14, courtesy of astronomy.com. And there is a picture. I'll bring this picture up. There it is. In this image you're seeing on YouTube and the repeater, scientists adjust anti-gravity bands for an astronaut. The gravitational force is by far the weakest of the four forces of nature. It's simple to defy gravity, just lift something in the air. But the annoying thing about gravity is that it's both persistent and has an infinite range, which takes a surprising amount of work to overcome. Gravity is so weak that even if it were 1 billion times stronger than it is now, it would still be the weakest of all forces. The whole mass of Earth is pulling on you, but you can reach over and grab a pencil and overcome the entire gravitational might. Naturally, eventually, you'll get tired and put the pencil down, but we do have other methods to magically overcome the strength of gravity. The magnetic force can keep an object suspended on the side of your fridge for eternity, but even stronger magnets using superconductors can levitate entire train cars, enabling super fast transportation that flows above the track, I say. Going further, it's not all that difficult to defy gravity and get into space. After all, the edge of space is just 62 miles or 100 kilometers away, and shooting something straight up for that distance is not the hardest thing to do in the world. Well, depends on your point of view. But gravity does have a superpower. Even at the edge of the atmosphere and the beginnings in space, Earth's gravitational pull isn't much weaker than what it is on the surface. So, unless you keep accelerating, eventually gravity will pull you back. Most of the energy that we put into rockets doesn't go into getting into space or getting to space, it goes in staying in space. If you want to escape the gravitational clutches of Earth altogether, you must achieve a speed of about 25,000 miles an hour, or 15,570 kilometers an hour, which is around 33 times the speed of sound. Once in space, we have some methods available to simulate the effects of gravity. This is important because a constant gravitational pull is vitally important for maintaining healthy bodies. Without gravity, our hearts grow weaker, our bones get thinner, and an entire cardiovascular system diminishes. Without constant exercise, astronauts who spend too much time in zero gravity couldn't survive a return to Earth. Engineers have developed concepts of rotating space habitats to create the effects of gravity instead of a massive object on the Earth pulling on you. The wall of a spacecraft would spin and fling you against the outer wall. The centrifugal force would give you the exact same sensation of gravity that you have on our planet, saving you from the ravaging effects of zero-G. All that technology still lies in the world of science fiction, but space agencies around the world are interested in developing such habitats for long-term missions in space. Speaking of science fiction, writers and authors love to come up with all sorts of gravity-defying gizmos, whether to provide artificial gravity for their ships or to propel their spacecraft through the universe. Unfortunately, it seems that these kinds of anti-gravity devices will remain in the realm of fiction. To operate these devices, it would require the use of negative matter, which is a form of matter with negative mass, not to be confused with antimatter, which is like normal matter but with opposite charge. We have never observed negative matter in the universe, and we strongly suspect it can never exist, because it would violate our understanding of the conservation of momentum, which is a pretty big deal. However, at the larger scales in space, we already observe an anti-gravity effect. We've known since the observations of Edward Hubble about 100 years ago that our universe is expanding over time. The average distance between galaxies grows. But in the late 1990s, two independent teams of astronauts discovered something remarkable. Not only is the universe expanding, but the expansion is accelerating. The universe is expanding faster and faster every single day. The name we give to this phenomenon is dark energy, and it appears to be an anti-gravity force which is propelling all the matter in the universe. Anti-gravity actually isn't all that strange in Einstein's general theory of relativity, which is the set of equations we use to understand how gravity works. In general relativity, any kind of tension, like the tension in a stretched rubber band, creates an anti-gravity effect. But usually this anti-gravity effect is completely swamped by normal attractive gravity, which we're all used to. Well, that was interesting. You'll find that on astronomy.com. Under the news tab. Alright, I think it's time for... I see, I was going to put that first, next. Yeah. No, I'll go straight to Tamitha, I think. Alright, stand by for the Space Weatherwoman, Tamitha Skov. Let me see if I can just bring her up. There she is. And if I'm lucky enough, I think the audio should come through without a problem. Let me see how this goes. You're tuned to ASV Radio. This is Tamitha Skov, Space Weatherman. This goes for about 13 minutes actually. This report's quite lengthy. Let me see how it goes.
We have multiple solar storms launched toward Earth that are on their way, and a whopper of a solar storm was just launched on the sun's far side. Those stories and more in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops.
Let's see.
Space weather this week has gotten really exciting. Now, we haven't had a lot of big solar flares, but we've had so many solar storms launch, I can hardly keep track of them all. As we take a look at the Earth-facing disk, here in the west, right around the 10th, beginning into the 11th, whoosh, you can see a big filament eruption that launches westward, but it has a slight Earth-directed component, and then about a day later, whoosh, there's another filament that erupts and it goes southward of Earth but also has a slightly Earth-directed component. Then advance another day and you can see we've got a big filament eruption, whoosh, that goes to the east of Earth, but this one also might graze Earth just a little bit to the east, along with a big prominence eruption that launches a solar storm way off to the east that's not going to hit us. And then we have another eruption that launches a filament north of Earth. My goodness, we've got a lot of solar storms that are either on their way to Earth or going to graze Earth one direction or another, and we'll talk more about that in a minute. But believe it or not, there's one big eruption that we haven't seen, and that is a massive solar storm that was launched on the 13th and to the sun's far side, and you can see it here in coronagraphs. Look at this massive halo. In fact, this was such a large eruption, it actually also launched a radiation storm, and we're feeling that here at Earth, and we'll talk more about that in a minute as well. Meanwhile, as we kind of take a look at our JSOC far side helioseismology monitor, you can see what we believe are the regions that might have caused this big eruption that we can't see. This region 3234 and possibly region 3236. These were big flare players back from about 2 weeks ago, and it looks like they're causing havoc on the sun's far side, so we're going to be watching them quite closely as they return because we may have big flares back on the menu and possibly big solar storms too. Switching to our M-flare threat meter, as we take a look at the X-ray flux, we can actually see that over the past week it's kind of calmed down just a bit. We don't have any real big flares on the menu. In fact, the X-ray flux has actually dropped a little bit below the seafloor, and that means by proxy the solar flux has also dropped a little bit. We're sitting in the 140s to 150s right now, and that's going to continue easily over the next few days. This is good news for amateur radio operators and GPS users. Our risk for radio blackouts right now is really low. We're only sitting at about 5% for an R1 level radio blackout, but this is not going to last for very long. So enjoy the decent propagation and the lower noise on the Earth's day side, because this is going to change, especially when those big regions, old region 3234 and 3236, rotate back into Earth view in about 4 days. Expect that the solar flux to rise as well as the X-ray flux and the noise on the radio bands. Now, taking a closer look at that radiation storm, you can see back on the 13th, you can watch those radiation storm levels begin to rise. And this was due to that big far-sighted solar storm that was launched. Believe it or not, the radiation storm made it all the way around the sun and it was being seen at Earth. In fact, over the last 24 hours, we've actually been kind of hovering around that S1 threshold, which is the lowest threshold for radiation storms. So it's not a really intense radiation storm, but nonetheless, it's still hanging in there. And this means that if you're dealing with high latitudes, if you're dealing with radio communications or GPS reception, you're going to be impacted easily over this next day. And this also means that any pilots, please, whether you're a drone pilot or commercial pilots, please be aware, pay attention to those ICAO advisories, because they're out right now. They'll help kind of guide you through this storm and how long it's going to last. And if you're a frequent flyer, especially if you're a high-risk passenger, just understand that over the next 24 hours or so, you are getting an elevated dose of radiation. So just keep, plan that put that into your flight plans and expect things to get better over the next day, and probably within the next couple days, things will be back to normal. Now, switching to our solar storm conditions, Over the past week, we've actually had a little bit of activity. We did have a pocket of fast solar wind from a big coronal hole that had rotated through the Earth strike zone, and it gave us some decent active conditions over, the 5th and the 6th, and maybe even bumped us a little bit to storm levels before things began to settle down. Since then, we've been kind of sitting at unsettled conditions. We did get a little bit of a bump up again right around the 9th to get a little bit of aurora, especially at high latitudes. But for the most part, we've been kind of sitting between unsettled conditions and even quiet conditions, but these are not going to last because we do have those Earth-directed solar storms that could easily bump us back up to storm levels. Now, taking a closer look at those solar storms that are on their way to Earth, this is our solar storm prediction model, ENLIL. This is NOAA's version of the model. The top panel's density, the bottom panel's velocity, and you're looking down at the sun from the North Pole with Earth being off to the right. And you can see that solar storm being launched. It's actually 2 solar storms. These are the 2 that are launched to the west of Earth. But as you can see, there is an Earth-directed component. It's definitely going to graze us right around late on the 14th and probably early into the 15th. And we should see a little bit of storming there. But what is not being shown is the NASA model of the solar storm that was launched to the east of Earth. And that one, as it launches, it actually looks like it's coming out and is going to graze Earth about midday or maybe in the afternoon of the 15th. So we're going to get kind of a 1, 2, 3 graze. And that should be able to be enough to bump us up, hopefully to active and possibly storm conditions, and maybe bring some aurora down to mid-latitudes if the storm is intense enough and if it lasts long enough. So we're going to keep our fingers crossed. And aurora photographers, if you're at high latitudes, you could definitely get a show. If you're at mid-latitudes, well, we're going to cross our fingers and hope that it's going to be a good one. So what else does our sun have in store for us this week? Well, this is Stereo A. It's our partially far-sighted monitor. You can see here's Earth, here's the sun, and here's Stereo A staring at the sun just a tiny bit from the side. And as we take a look at Stereo A's view, you can see region 3245 begin to eke its way off to the west limb in Stereo's view. And you can watch a few of the big solar storm eruptions that have been Earth-directed. But if you look past that and look to the east limb in Stereo's view, and you can actually see a bit of glow. In fact, you can see a few loops beginning to form just out of view in Stereo. So what this shows us is that we've definitely got some new regions that are going to be rotating into Earth view, but it's going to take probably 4 days or more before that happens. And in between, we really don't have a lot in the way of big flare players. So what this means is you get a little bit of a respite from the big solar flares, but just beyond Stereo's view are a couple big players. Remember, region 3234 and 3236. Those are the ones that we're going to be watching out for, and they should be peeking around the corner here in just the next 2 or 3 days. So we'll start getting a better look at them, and as they begin to rotate into Earth view, we're definitely going to see that solar flux rise. We're definitely going to see that X-ray flux rise, likely get higher noise on the radio bands and a bigger potential for radio blackouts. So just enjoy this quiet, and also aurora photographers, who knows, maybe one of those regions might actually launch an Earth-directed solar storm. Switching to our moon, we are now passing through the 3rd quarter phase on our way to a new moon, and by the 19th, the moon will only be about 7% illuminated. So you night sky watchers, now's your great chance to catch those dim objects in the sky, and who knows, possibly some aurora. Switching to your solar storm conditions and aurora possibilities over the coming week, we are anticipating the hit from those multiple solar storms that are on their way to Earth. In fact, at high latitudes, we could get some extended storming. But NOAA is expecting minor storm conditions with up to about a 70% chance of a major storm at high latitudes, and the storming could last through the 17th before things begin to settle down. So aurora photographers, you could get a good chance and a lasting chance to get some decent views. Now, at mid-latitudes, the story isn't so bad, all things considered. We are expecting minor storm conditions, and we do have up to about a 15% chance of a major storm. Although things aren't going to last quite as long, it should start settling down right around the 17th. So aurora photographers at mid-latitudes, well, the 15th and the 16th could be their best chance to catch some sights. Now, switching to our solar flare and dayside radio blackout outlook over the coming week, things right now are pretty quiet. We only have a few active regions on the Earth-facing disk, and they're really not big flare producers. So things are, as far as radio blackouts are concerned, are really quieting down. In fact, as we take a look at the solar flux, we're sitting in the 140s right now, which is still good for dayside radio propagation, so that's not a problem. And you can see that we are going to be ramping up in solar flux over the next week, up to about 155, possibly higher than that, as those regions that we're expecting to rotate back into view, region 32, 34, and 36. As those rotate back into view, these numbers will definitely climb. But at the moment, we are looking at only about a 5% chance of radio blackouts on Earth's dayside, which once again, we could ramp up to a moderate noise level right around by Saturday. Maybe we can get up to about a 30% chance of these R1 to R2 level radio blackouts. But all things considered, we have very low chance for X-class flares. Again, that could ramp up as we get through the end of the week and those new regions rotate into view. But take advantage of this. If you're a GPS user on Earth's dayside near dawn and dusk, things should look pretty good for you. And if you're an amateur radio operator, enjoy the quiet on the bands right now because it's not going to last. Switching to our radiation storm and polar aviation outlook over the coming week, right now we are sitting at a D2 minor level. This is the S1 radiation storm level due to that big solar storm that was launched on the sun's far side actually had a radiation storm along with it, and it's actually made its way to Earth. So over the next day or so, we're going to be dealing with elevated levels. We probably won't get back to the D1 normal range until about the 16th. So if you are a pilot, definitely take a look at the ICAO advisories, as they are going to be coming out easily over the next day or so. And if you have to deal with HF communications or GPS and navigation at high latitudes, just understand you are dealing with this stormy conditions right now. And also, if you are a frequent flyer, and this does include air crew as well as prenatal passengers, just understand you're getting a higher elevated dose right now of radiation, so please take this into consideration in your flight plans. So the space weather this week has gotten very exciting. We have multiple solar storms that are on their way to Earth, and it looks like the impacts could start as early as late on the 14th into the 15th, and then again about midday on the 15th. So aurora photographers, both at high latitudes and mid latitudes, you could be in for a show, so definitely keep your batteries charged. Now, amateur radio operators and GPS users, well, right now, we don't have a lot of risk for radio blackouts, and that's easily going to last over the next maybe 3 or 4 days before those big regions on the sun's far side begin to rotate into view. So enjoy decent radio propagation on Earth's dayside with some low noise, unless, of course, you're sitting at high latitudes, because right now we have that S1 radiation storm, and that could cause havoc for HF comms and GPS reception if you're at high latitudes. So definitely understand you're going to be dealing with that over the next day or so. And also pilots, please make sure you pay attention to those ICAO advisories, because they'll let you know when that radiation storm is going to die down, which should be over the next couple days, and then things will finally get back to normal. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Right. Thank you, Tamitha. Dear, apologies for the audio aspect to that at the very beginning. Once again, I've been using the mixer, the 16-channel Behringer, which you can just see in the back here downstairs, for a couple of other things I've been doing. And of course, I brought it up just about an hour ago before the broadcast and quickly hooked it in, and forgot to connect the USB cable, which connects the mixer to the system. So I think we've got that all sorted out, and managed to get Tamitha in her 13-minute report through. So it covered today and tomorrow, so I figured it was worth giving it a go. All right, well, I can see that it's 10 past the hour, and I'll just quickly go into spaceweather.com just to get the very latest and a few other details here. Okay, solar wind is currently at 433.4 kilometres a second at a density of 6.35 protons per cubic centimetre. The current disk of the Sun, which is this, audio drops off, there we are. That's the current disk of the Sun, with about 1, 2, 3, 4, 5, 6, 7 sunspots there on the current disk. And the aurora over the South Pole at the moment is looking like this, and the audio is still there, good. So there's not a whole lot of auroral activity here. There is a ring, but it's very faint, so not too much to write home about. And as far as I know, I show this. I've been showing this for the last few weeks, but that's the current solar cycle where we are. In the scheme of things, so yeah, it's still picking up pretty quickly. All right, what else? The radio sun is currently at 135 solar flux units, 135, measured at a wavelength of 10.7, and just seeing if there's anything there. They're making reference to superior conjunction of Mercury. Are you looking for Mercury? Don't. Today it is only 1.5 degrees from the blinding sun. So they've got a little image, GIF image here showing where the position of Mercury is in relation to the sun. So astronomers call this event a superior conjunction of Mercury. Right now the first planet is on the far side of the Sun, passing almost directly behind. So there it is. And as far as the KP index is concerned, planetary K index, at the moment the KP index is 2.00, which is considered quiet. The 24-hour max KP figure will be still 2.00, considered quiet. And as of March 17, 2023, there were 2,325 potentially hazardous asteroids, none of which we have to worry about. Okay, on that note, we shall conclude tonight's session, and I thank you very much for hanging in there for the extra extended service. I thought it was going to be a short session, but there it is. Thanks to everybody that's up on the Discord. I note that Andrew at VK3, both Andrew and Don, Andrew KIS and Don HDX, have made note that because of the website has changed, the ASV website has changed, the links that we had provided for YouTube and Discord have caused a bit of a disruption to some of the folks out there. So I'm not sure what the answer is to that, but certainly for my YouTube channel, it's just a matter of going to YouTube and typing in my call sign VK3CSJ and look for the live symbol, and that will get you to the YouTube stream. I don't know whether there's any value in creating a special link on the ASV website. I can probably talk to Lee about that and see what can be done. I know that he has provided a media link under the radio astronomy section tab. There's a link to media, and that kind of provides a link to the QRZ.com page, but it's still not quite exactly in the right direction. So, more, as I've said in the past, more information about the station here can be found on the QRZ.com page. Type in VK3EKH, but that's not what we're talking about here. Anyway, on that note, we'll conclude our transmissions for the 17th of March, and we'll go across to 80 metres now. In fact, I'll take these headphones off because they're a damn nuisance. Oh, that's better. And I shall give a quick call to see who there is that wants to check in. So this is VK3EKH listening on 3541 kilohertz.
VK3 Juliet Romeo. VK3SPX.
Okay, acknowledging VK3JR and VK3SPX. Anybody else? There was a weak station there. Who was that? Oh, I think it was VK9, Whiskey X-Ray. Well, we'll find out where you are in a moment. VK3JR, g'day Frank, have a say. VK3EKH.
VK3EKH, VK3JR, that's 9WSD Dollars. That's interesting. So with the broadcast, thank you very much. Always enjoy Tabitha, of course. One thing, I don't think you read out the solar number. You read out the A index and the K index, but I don't think you read out the actual the number, sunspot number, which is a pretty important one. Otherwise, thanks for doing it. Good evening to everyone on frequency 73. Have a good week, everyone. And we'll talk next week. And there are tipping emissions for those interested. VK3EKH, VK3JR.
Yeah, thanks Frank. What was the number that you were after again?
It's a number that I think it's just referred to as the solar number. It's a three-figure number these days, 100 and something. And I'm not sure how it's derived, but I think it's just known as the solar number. You read it out normally.
Ah, okay. I didn't do that. Maybe I didn't. Okay. I'm not really seeing that directly there, but maybe it's the sunspot number. I usually read out the solar wind and the density figure. The sunspot number is 84. I didn't say that. Read that out. The radius on is 135. And I've been including the K index now because I think that's what you were interested in, the KP index figure. And that's all I can see, which is what I would normally read out, I think. Does that sound about right, or is it definitely another number I should find?
No, you're right. It's the one you didn't read out, 84, the sunspot number. That's dropped below three figures, which is not a good sign. But it'll come back. It's 84.
That's correct, 84. Okay, yes, I do apologise. I didn't read that out, I must admit. Okay. Good on you, Frank. And okay on the 160 metre missions too. Not a problem. Thanks, mate. We'll make sure we'll include that for next week. All right, Steve, VK3SPX. How did I say? VK3EKH.
VK3EKH, VK3SPX. My logging program says the SFI is 135, so I don't know quite exactly what that is, but I think that's one of the other numbers Frank was probably looking for. Actually, I think today probably don't really qualify as a callback clip because I only got back here about 20 minutes ago and just caught your last article about gravity as I was at a meeting at the radio club. But yeah, I did think the possibility of spinning spaceships to create gravity is probably the way to go over the long term, unless someone suddenly invents a gravity machine, which seems unlikely. So I was just reading, if you want to spin something to create gravity and you don't want people to think that's any different, it needs to go around about 1 RPM, which means it needs to be 900 metres in radius. And maybe you can get away with 3 RPM without making people too ill, and that would need to be 100 metres. So there's a pretty big spaceships, aren't they? So I don't think we're going to do that anytime soon. Anyway, Clint, sorry I missed most of it. I'm sure it was interesting as usual. I'll try to catch the whole thing next week. All right, keep up the good work. VK3EKH, this is VK3SPX.
Yeah, no worries, Steve. That's fine. VK3SPX, VK3EKH. Look, even though you probably weren't watching the footy, I know that the football is back and happening, and I know tonight there was another football game, so I suspect that a lot of crazy football people are probably watching the TV, although I think it's finished now anyway. Although I don't think that's what you were doing. But look, no worries. We're definitely gone over time tonight. I really didn't expect that, but there it is. It's all right. Anyway, no worries, Steve. Thanks for calling in. It's not a problem at all. Now we've got VK9 Whiskey X-Ray, VK9WX up there at Willis Islands, I believe. Hope the signal is good. VK9WX, VK3CSEKH. The name here is Clint. Charlie Lima India November Tango. Clint is the name, and my normal call sign is VK3CSJ. VK3 Charlie Sierra Juliet is my own call sign, but we're using the official call sign for the Astronomical Society of Victoria, the ASV. VK9WX, VK3EKH. Go ahead. Yeah, quite not very strong. I think it's SANS. I'm looking at your QRZ.com page, SANS or Sandeep. I used to know a JDeep once, but I think it's SANS. Is that correct? Yeah. Yep, got the QSL. All right, no worries, Sans. Great to meet you on the air for the first time. And you're just in my noise level. You're just on my noise level here. I've got about a strength 9 noise level here in Narre Warren, which is not too far from Melbourne. And unfortunately, the suburban noise floor here is pretty horrible. My kingdom for a quiet RF location. I suspect that where you are on Willis Island, the noise floor is probably 0. I can see a picture of it here. Must be a sensational place to be, and I can see the antennas set up there next to a couple of dishes, and the simplistic station. And I don't know whether that's you sitting at the desk there. We can't quite see your face, but I'm not sure if that's you sitting at the desk, but maybe it is. But look, thanks very much for calling in. You're in the logbook officially, and great to hear you. But like I say, not very strong here. Not very strong. I've actually put the headphones on to try and pick you up a bit better. I'll pop it back to you there, Sans. W9, VK9WX, VK3CEKH. I'm all over the place. Go ahead, Sans. Yeah, Roger Sands, get it right, Clint. VK9WX. I want to give you an American call sign for some reason. I don't know why. Oh dear. VK9WX, Willis Island, VK3EKH, returning. Very good. Thanks, Sands. Thanks very much for coming up and giving us a report. And I think you said I was about strength 9 or so coming up there. That's not too bad. I'm very happy about that. But I would give you about readability 4, readability 3 to 4, and hovering around strength 8 to 9, strength 8 to 9. But that, again, you're right on top of my noise floor, so it's just making it a bit difficult. But excellent, Sam. Yeah, well, we're here every Friday night. I do a broadcast. I do an astronomical broadcast on behalf of the ASV, the Astronomical Society of Victoria, every Friday at 10 o'clock on this frequency. We usually kick it off. And I normally have a simulcast on 160. I also have a secondary broadcast on 160 at the same time on 1865, but my transmitter for 160 is currently off air, so we're just doing it on 80. But look, more information, you can find out more information about the station here on qrz.com. Just type in VK3EKH on the QRZ page, and that'll pretty much fill you in. Thanks, Sam. Really appreciate to hear you. Thanks very much for calling in. It's really excellent stuff indeed. VK9WX, VK3EKH. Yeah, Roger Sands, VK9WX, VK3EKH returning. Yeah, I'm only catching the odd word. I'm only just catching the odd word from you, but I can see on the QRZ.com page that your regular call sign is VK4 Whiskey X-Ray Whiskey. Yep, no worries at all. I can QSL on that. That your regular call sign is VK4 Whiskey X-Ray Whiskey. Not a problem. And that you're based there at the moment for a cyclone warning service to Queensland, which is really interesting. Yeah, it must be really interesting. Yeah, all right. Okay, excellent stuff. I know that there's been a cyclone that's travelled right across the Indian Ocean there. It started out from the west coast of Australia and headed out towards Madagascar and hitting the south part of South Africa. It's a very, very rare cyclone. I think it's Freddy from memory. I think it's called Cyclone Freddy, and it's travelled right across the Indian Ocean. Oh, you know all about it. So it's a pretty amazing weather pattern that's been happening and causing horrible things to go wrong over there in Madagascar, and yeah, not good at all. Anyway, all right. Thanks, Sands, and take it easy on Willis Island there. It looks like a lovely holiday place. Anyway, cheers, mate. We'll hopefully catch up with you on one of the other HF bands that might be stronger signal. VK9WX, this is VK3EKH. Yeah, Roger Sands, thanks very much, mate, for calling in. Just a little bit hard to copy, but hopefully we'll catch up with you maybe on another HF band that provides a slightly better signal. Cheers, mate. Take care. Look after yourself. VK9WX, VK3EKH, VK3CSJ on the microphone is clear. And if there's any other stations wishing to check in for tonight's broadcast, please come up, VK3EKH. Oh, g'day, Martin. Go ahead. Yeah, thanks, Martin. VK7, JAH, VK3, EKH. Yes, thank you very much, Lee. You're about 15 to 20 over 9, so it is good propagation tonight, that's for sure. And it's certainly good to get out to Willis Island, so there it is. Yeah, look, apologies for the stuff up with the YouTube arrangement. I know that I usually always make reference to the ASV website to be able to see the YouTube channel, but I also mentioned just type in VK3CSJ in the YouTube search engine, and it's the way to find me easily enough. But like I say, I'll see if I can get Lee to provide some sort of direct link to the YouTube channel and also the Discord, and try to get that all sort of tidied up, so that yeah, make that a bit easier for folks. All right, thanks, Martin. And have I ever run short, you say? Yeah, no, I haven't really. Thanks, Martin. Anyway, cheers for now, and if there's nobody else, we'll clear off. The K3 EKH. No worries, Martin. Okay, this is VK3 Echo Kilo Hotel, the official station for the Astronomical Society of Victoria, concluding our transmissions for tonight. Thanks everybody for listening and tuning in, and to everybody there on the Discord channel, and the couple of emails that I've got up there. All thank you very much, Lee. And we'll see you all next Friday to do it all again, and hopefully keep it within the hour. And yeah, let's have a nice safe week. It's going to be a hot one down here in Victoria, so stay cool. This is VK3 EKH with VK3CSJ on the microphone, concluding transmissions on 3541 and the YouTube stream, and we'll see you all next Friday. Take care, everybody.
VK9WX, this is VK3SPX. Are you still there, Sam? VK9WX, this is VK3SPX. VK9WX, this is VK3SPX. Hello, Sam. Yeah, I haven't had a VK9 in my log before, so great to hear you come up on the Astronomical callback, and good to hear you, and fantastic place you must have there. I will say that my name is Steve Sands, and I'm in central Victoria, just not far from Bendigo. Over.
He's not quite strong enough here.
Sierra Puppet X-ray SPX, over. Your 4747 varies between 47 and 57. Make out most of what you can say. A little bit like Clint, you're just peaking above the noise level a bit. But great to talk to you, Sands. Over. WX VK3SPX. Yes, great that you could join. I think VK9 quite unusual. I don't know if it's a first, but certainly unusual. Anyway, great to hear you say that the conditions aren't brilliant, so I won't keep going for long. But 73 to you, and enjoy your time on Willis Island. This is the K3SPX coming clear. Much appreciated. Great evening. VK3SPX, we cannot up here. How's your evening, Steve? 73? I think you're saying 73.
Well, there it is. So, good on you, Steve. I'm not sure if you're catching up with my YouTube stream, but I've just managed to get that little contact on the YouTube stream, and I believe that's Sandeep up there operating on Willis Island, and I used to know a JDeep. So that's when I used to work for NEC, I think. Anyway, so there's Sandeep on the screen right now. It's a courtesy of this QRZ page, and that's the view outside his shack window, looking out of Willis Island. There, it's pretty. Oh, okay. So yeah, there it is, and not sure what that's all about. But there's his antennas, a vertical. If that's his 80-meter antenna as well. I can't quite read the text there on that, but. Definitely a full-length dipole would be the thing to have up on Willis Island. It's not much to it. You wouldn't want to have a tsunami occur. I suspect that that island would be successfully wiped out, temporarily at least. Oh dear. Anyway, there it is. We had a very interesting contact. Sands W. Why do I keep saying W? VK9WX. I'm tired. I am tired. That's what it is. Alright. Cheers everyone. Thank you for watching, and we'll be back next Friday to do it again, and hopefully I'll have things a bit better organised. Probably not, but there it is. If everybody's still up on Discord, thanks for watching, guys. Cassiopeia, Martin, Lee, I think Lee's disappeared, and Richard. I don't know if you're still there, Richard. I'm listing 23 centimeters. Wrong mouse. Who else was there? Stuart, VK3A UAO. My dyslexia is really playing up tonight. Not that I have that, but sometimes I wonder. Anyway, yep, everybody's there. That's great. Thanks, chaps, for calling in, making the chat window sing. Cheers, everyone. We're out of here. This is VK3 EKH or VK3CSJ on the microphone. We'll be back on Sunday morning to present the WIA broadcast, courtesy of Bevan, VK5BD, and his visuals, and we'll repeat that at 8 o'clock Sunday night, and then there's the ATV net on Tuesday night, courtesy of Neil, or maybe Ian, depends who flips the coin, and there it is. So have a cool weekend, stay cool. I think tomorrow's going to be the worst of it, because by 6 o'clock the temperature's going to drop, so it's just tomorrow. It's going to be unbearable. Anyway, enough of me waffling here. There's not much more just to show and do. So we shall conclude. Take care, everybody. Stand by for colour bars. This is VK3 EKH, VK3CSJ on the microphone.